Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it. Let's do it together. So we want to find the value of x. We want to find side BC. Now, I am told that quadrilateral ABCD is similar to quadrilateral QRST. So, ABCD, QRST. So these shapes are already in the correct orientation. I know that the right side corresponds with the right side. The bottom side corresponds with the bottom side because the similarity statement lists these shapes in order of top left corner around clockwise. Okay, wonderful. So what I can do, and what I need to do, is set up a proportion. I know that side BC, which is x, that's what I'm looking for, corresponds with side RS, which is 4. So I can say x over 4 equals, now because x is on top, that's the first shape is on top, so I need to keep ABCD needs to stay on the top, and QRST needs to stay on the bottom. So if it helps you to write that out, you definitely can. I do it all the time. So now we're going to pick any other side from quadrilateral ABCD. Do you want the top? Do you want the left? Do you want the bottom? Whatever you want. I'll choose the bottom, which is 16, over the bottom of quadrilateral QRST is 8. Now, some of y'all might have noticed right off the bat, wait, 16 is 2 times 8, so x needs to be 2 times 4. You can totally recognize that. That's great. Some of you might not have, so some of you probably did butterflies and said, 8 times x is 8x, and 4 times 16 is 64. I'm going to double check that real quick. Yes, 64. And then I divide by 8 on both sides, and x is 8. Ta-da! And that was our cross multiplication, or our butterflies. So, that was a nice review of what we did in the last video. Now, let's move on to what we have for today. Today, we are continuing our work in section 8.1. We are going to continue to talk about similar polygons. Today, our learning target is that you remember what similar figures are. So, using everything we learned in the last video. And our success criteria is that you can find perimeter and area of similar polygons. So we need to be able to find the perimeter and area of similar polygons. Before we can find perimeter and area of similar polygons, we need to remember a few key vocab words. So, remember ratios and proportions. Ratios is like 1 fraction. We can write the ratio of 4 to 1 as 4 over 1. A proportion is when 2 fractions or 2 ratios are equal to each other. So that's going to be important for this lesson, as well as all lessons where we talk about similar figures. Speaking of similar figures, another vocab word review from last video. Similar figures are geometric figures that have the same shape, but not necessarily the same size. So, similar figures means that you can map one shape to the other through a dilation. And map just means that if I dilate one of the shapes, I get the other shape. You can also reflect and, rotate, but there needs to be a dilation that happened as well. Okay. All right. First important piece of information for the day is the perimeters of similar polygons theorem. So, this says, if 2 polygons are similar, we need to know. We can only use this theorem if the polygons are similar. So if the polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. So the perimeters and the side lengths are proportional, right? Because the ratio is equal to the ratio. When I set two ratios equal to each other, I get a proportion. So the perimeters and the side lengths are proportional. So remember that each of the side lengths, if we just look at this box I just drew, we have the ratios of all of the side lengths in this box. That's equal to the scale factor. So another way that you can say this is when two similar polygons have a scale factor of, let's call it k, that's what we call the scale factor, the ratio of their perimeters is equal to k. The ratio of the perimeters is equal to the scale factor because the ratios of corresponding lengths is equal to the scale factor. So, now, I'm going to take a look at, let's actually leave that k there. I'm going to take a look at this box I just drew. What on earth is PQ plus QR plus RS plus SP? That's the perimeter of the red polygon, right? Perimeter means that I'm adding up all of the sides. So I add PQ plus QR plus RS plus SP. Remember, the perimeter is if I walk around this shape, how far am I walking? So I just add up all of the sides. So this box is saying we have the red perimeter over the blue perimeter, the ratio of the red perimeter to the blue perimeter. Okay, so the ratio of the perimeters is equal to the ratios of the corresponding side lengths, or equal to the scale factor. So let's try an example using this knowledge that we have just learned. So, a town plans to build a new swimming pool. An Olympic pool, that's the size of pools they use in the Olympics. An Olympic pool is rectangular with a length of 50 meters and a width of 25 meters. So this is the Olympic pool. This is the Olympic pool. The new pool will be similar in shape. Similar in shape. So this is the new pool. Similar in shape to an Olympic pool, but will have a length of 40 meters. 40 meters. Find the perimeters of an Olympic pool and the new pool. Okay, so let me erase these lines. So we already drew our diagrams. So we want to find the perimeters of the Olympic pool and the new pool. So that's what we're trying to find in the end. Now, there's a very important piece of information that I want to make sure we don't lose. An Olympic pool is rectangular. Remember from chapter 7 that we just finished, rectangles are a type of parallelogram. And parallelograms have opposite sides that are congruent. So I know that in this pool, because it is a rectangle, I know that this side is 50 meters, and I know that this side is 25 meters. So, when this problem wants me to find the perimeter of an Olympic pool, well, I can do that. I can just add. So, we can say area of the Olympic pool is 25 plus 50 plus 25 plus 50, which is, let's see, 50 plus 50 is 100, 125, 150. So this is 150 meters is the full perimeter. Oh, I'm sorry, not area. Oh my, where did area come from? Perimeter. I'm sorry, perimeter of the Olympic pool is 150 meters. Now, how can I find the perimeter of the new pool? I know that this side is going to be 40 meters, but I don't know. I don't know what the other side, I don't know what the width of the new pool is. Now, you could use the fact that these are similar figures and treat this like the problem in the entry task. You could just say, this is x, and I can find x because these are similar figures, and then you can add up all of the sides. You could do that, but, and if that works for you, go ahead and do that. But we just learned about the perimeters of similar polygons theorem, which says that the ratio of the perimeters is equal to the ratios of corresponding side lengths. So what I can do is I can let's put the Olympic pool on top, and we'll put the new pool on the bottom. And then I'm gonna put their perimeters. Let's draw a line here so you can see the difference. We're gonna put the perimeter on the left, and then we're going to put the side lengths on the right. So, what is the perimeter of the Olympic pool? It is 150 meters. What is the perimeter of the new pool? We don't know. That's what we're trying to find, is the perimeter of the new pool. And the side lengths of the Olympic pool, the length is 50 meters, and the side lengths of the new pool is 40 meters. Notice how we used the bottom side and the bottom side. Stay consistent with what we're comparing in our ratios. When we take the length, we have to take the length. Otherwise, they're not corresponding. Okay, now look at this. Let me actually highlight it in a different. We have a proportion. So I can do my butterflies, my cross multiplication. I get 50x is equal to 40 times 150 is 6,000. Divide by 50 on both sides. And we get that x is 120 meters. 120 meters. And x is the perimeter of the new pool, which is what we wanted to find. We wanted to find the perimeter of the new pool. Yay! So let's do a short little recap of this problem. We had all the information we needed to find the perimeter of the Olympic pool, and then we drew our diagram comparing the fact that the Olympic pool and the new pool are similar shapes, and then we were able to set up our proportion using the perimeter of similar polygons theorem. So let's check and make sure that we were correct. Yes, 40 to 50. Oh, okay, they simplified 40 over 50 to 4 over 5. They canceled out the zeros to make the numbers easier to work with. And they put the Olympic pool on the bottom and the new pool on the top, but that's okay, because they also got 120 meters. So, woohoo! Oh, and they even checked. They checked that 120 over 150 was actually equal to 4 over 5. So, and they could see that they were correct. So you can also do that anytime you want to check your answer. Set up another proportion and make sure that they are actually proportional. Okay. Another theorem for today. This is the second piece of important information, and then we'll move on to our last example. So, areas of similar polygons. Remember that the learning target and the success criteria mentioned finding the perimeter and area of similar polygons. So, the area of similar polygons theorem says if two polygons are similar, so if two polygons are similar, if we don't know that they're similar, we can't use this theorem, then the ratio of their areas is equal to the squares of the ratios of their corresponding side lengths. So, we can take the area of the red shape over the area of the blue shape, and that needs to be equal to PQ is the top, KL is the top. That needs to be equal to the ratio of the side lengths squared. So basically exactly what we did with perimeter, only we're adding a square. We are squaring the ratio of the corresponding side lengths. Square. Okay? Oh yes, so when two similar polygons have a scale factor of k, the ratio of their areas is equal to k squared. So we can also say equal to k squared, or the scale factor squared. If you like working with scale factors, you can do that too. Okay, so let's do an example. In the diagram, triangle ABC is similar to triangle DEF. Find the area of triangle DEF. Well, I know that the area of ABC over the area of, triangle ABC over the triangle of DEF should be proportional to the side. This is the only side they gave me, and I need to keep, because triangle ABC is on top, I need to keep the side from triangle ABC on top. 10 over 5 squared. Okay. So now, oh, and I guess we could put, since, so we're talking about the area of triangle ABC. This is equal to side AB over side DE squared. Now we can plug in our numbers. So, the area of triangle ABC, they told us, is 36 centimeters squared. Over, we don't know what the area of triangle DEF is, so let's call it X, equals AB is 10, over DE is 5, squared. Oh, centimeters. Squared because we're working with area. Remember, area is two-dimensional. That's why we need to square things. We have centimeters squared because area is two-dimensional. Perimeter is just one-dimensional. It's just length. Area is two-dimensional. Okay, look at that. Now we have a proportion. We can cross-multiply or make our butterflies. Oh, wait a minute. Boom, before we do that, let's simplify some things. We have 36. Let's just leave off the units for now. 36 over x equals 10 squared is 100, and 5 squared is 25. There we go. That'll make it easier when we go to do our proportion, or our cross multiplication. And now I have 100x equals 36 times 25, which is 900. If I divide by 100 on both sides, I get that x is equal to 9. So that would mean that the area of triangle DEF is 9 square centimeters. Centimeters squared. That number seems too small to me. Let's check and make sure that we were correct. Oh yeah, okay. 9 square centimeters. This is why it's good to check your answer, because I thought, I was like, we did everything right. I know we did everything right, but 9 just seemed like a small number. But we did everything right. We set up the same proportion that they did, substituted the numbers in, and then we squared. 10 squared is 100, 5 squared is 25. We cross-multiplied. 90 equals 100. We used x instead of a, but that's okay. And yeah, the area of triangle DEF is 9 square centimeters, which is what we got. So, yay! Alright, that is all I have for you today. Just perimeters and areas of similar polygons. So, now is a great time to rate yourself on your understanding of our learning target and our success criteria. Do you remember what similar figures are? Do you understand what similar figures are, how they're related? And can you find perimeters and areas of similar polygons? Do you understand how the perimeters and areas of similar figures are related? So, rate yourself on a scale of 1 to 3, where 1 is, I need some help, I don't know what's happening. 2 is, I think I got this, I need to try some homework, see how I feel. And 3 is, oh, this was great, I felt really good about this, and I can't wait to finish my homework and help all of my friends with their homework. So, if you need to ask questions, if you need to try the homework, if you need to help your friends, take the appropriate action for wherever you are, however you rated yourself on that 1 to 3 scale. Here are some practice problems that you can do to practice the skills that you have learned in this video. The ones on the left are like example 4, and the ones on the right are like example 5. And, as usual, let's end our video with a launch. Today's launch comes from Anthony J. D'Angelo, and he says, develop a passion for learning. If you do, you will never cease to grow. You will never cease to grow. Ooh, don't we all want to keep growing? Like, you don't want to stay the way that you are forever, right? Like, when I think about this, I think about my grandparents, and I think about, like, how, like, their relationship is amazing. Like, they are kind to everyone. They are patient. They are, like, they're my role models, you know? And they didn't get that way by refusing to grow. Like, they grew and changed themselves their whole life to get where they are. So I never want to stop growing. I want to become my grandparents, right? I want to become a more kind person. I want to become a person that knows even more math. I want to become a person that can empathize with other people and that can help other people. If you develop a passion for learning, you will never cease to grow. If you have a passion for learning and you just want to learn more, you're gonna keep growing. When I was in high school, I did not have a passion for learning. I had a passion for good grades and making my parents happy. So I got good grades, but not because I was really learning. You know, it was more just to check the box that, oh yeah, I got an A in that class. Oh yeah, I got 100% on that assignment. But I didn't really have a passion for learning. It wasn't until, like, I graduated from college that I went, oh, I wish I could go back and, like, get more out of my education, because I didn't really have a passion for learning in the beginning. So, if you can, and it's all in your attitude, if you can develop a passion for learning and you can want to learn and you can be fascinated, not by the grades, but by the material and what you're learning, you will never cease to grow. And this extends outside of the classroom too. This isn't just about having a passion for learning math. This is a passion for learning about other people's experiences. What other people go through on a daily basis. How a certain event impacts other people. This is a passion for learning anything. How to have better relationships. How to listen to people. How to empathize. You know, yes, I could talk about this for a long time. So, if you develop a passion for learning, you will never cease to grow. So, is growing something that you really value? Hopefully it is. If it is, develop a passion for learning and think right now, think today, how can you develop a passion for learning so that you never cease to grow? So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.